So, as you know, the talk is basically going to focus on the backup and recovery management capabilities and the tool that we are going to discuss. But the basic notion, of course, here is that people want to have a service with sort of a zero downtime. But that's is it something that exists in the real world? Let's just take a look and see who exactly wants a service like that. Well, basically everyone, as I would assume. Now, is it something that's just about technology? Well, I'm afraid so. It's not. It involves a lot of other stuff, majorly your risk assessment, your procedures, and people especially who are actually dealing with all those procedures that are in place to keep you running and keep your services running. Now, where exactly this topic leads us to, it's basically about some of the technologies that exist already, but the concept is the backup and recovery management within your services. Myself, I'm Haroon. I represent second quadrant, and although I see that Samir has already introduced me, so I did not want to kind of, although this talk is about backup, so I did not have a backup introduction myself, which is not good, but I skipped that part. Anyways, let's move on to the important stuff here. What is important is to know the stuff about your business continuity. So that concept basically involves some of the stuff that's mentioned here: the disaster recovery, your high availability types of disasters and failures, the availability uptime, which is basically sort of a ratio between your uptime and the uptime plus downtime. Now, we do understand that disaster recovery and high availability, we've been hearing these terms a lot in recent times. These two principles, basically, disaster recovery means the amount of risk that you can take with respect to your data loss when you have a disaster, during a disaster, or after the disaster. So what amount of data you are ready to lose? The notion basically revolves around that. High availability, this basically revolves around the idea of how much time you actually need to come out of a disaster once you have it. So what sort of a policies you have in place before the disaster happens, during the disaster, and once it has happened, and what sort of a policy you have in place to recover out of it. So the idea is that these two should be the minimal in terms of your service level, which is why the last availability function will become one of your important goals and data points over the cycle of your service. So the objectives, let's define what basically we want to look at. The important concepts would be recovery point objective, which is the idea how much data I can afford. Basically, the disaster recovery concept, we are extending it to the RPO concept. So how much data I can afford to lose once a disaster happens? That's, of course, everybody would want to say, no, we don't want to lose any data. But is it so? Let's take a look at that in the following slides. Recovery time objective, how much time can I afford to stay down once a service goes down due to any disaster? Again, the logical answer to that question would be, of course, you don't want to stay down for any longer once the disaster happens. You would want to recover soon enough. But the cost of downtime, unfortunately, we know it's something that impacts businesses directly. It translates into direct revenue that you earn. It basically impacts your revenue streams. So what you need to do is you need to define your SLOs, SLAs, and then SLIs according to that. But your SLO is basically your numerical, the precise numerical target for your service availability. So you would want to define what sort of a service availability you would want to have within a given time frame. As an example, you would want to have a 99% of uptime during a year, or 99.9%, or maybe another 9. So what exactly you would want to go with, it's basically something that you need to define at the very outset, which is going to be your SLO in the following slides. Basically, that's what I'm going to refer to it as. Then you have your SLA, which will basically mean that you have some sort of an indicator somewhere that you would want to use when you are measuring your SLAs. So you will sign some SLA in terms of your service availability, but how do you measure if it is meeting that SLA or not? You'll need to find some sort of an indicator. The indicator would be your SLI, which is the successful probes of your service over a period of time. So let's say you check your service 3 times a week, and if it comes back 3 times a week successful, that means you are meeting your SLA. So your SLI is basically the measure of that. So when you are designing any disaster recovery technologies or any disaster recovery mechanisms or policies, you need to keep some of these concepts in mind. Now, with respect to some of the material that we are discussing here in these slides, a few assumptions are that we are assuming that we are running on Linux. Also, we are assuming that we have a server which can be a physical server or a virtual server, but your important point here is your storage. It should be redundant. You either have a RAID or you have a volume which is basically mounted as a redundant storage. Why this is important? That's a separate debate. But let's for a moment focus on the topic that we have at hand here. So where do we start from? I mean, you have a 0 RPO, a 0 RTO to start with, because you have just one Postgres server. So we'll basically build on this idea and then take it to the next level. So at the beginning, once you start, you basically have just one server which does not have any disaster recovery policies configured. So you're basically at a 0 business continuity level. The architecture, it would look something like this. And of course, the name of the server is pretty logical here. We're just hoping that nothing happens to it, right? So let's name it hope. And I know that some of us feel it's not something that's in business, but for people here who deal with clients, I'm sure they would know that this is more often than not the scenario in many of the cases. We do come across people, we do come across with queries coming in when people are in panic because they did not have any policies in place. They were running just one server and that's it. So they were hoping it doesn't happen. I would say that for people, if any of those are here, you should probably appear in any of the I Love Adventure soft drink ads. But anyways, your RPO in this particular case is completely undefined. You don't know, because you really don't know how much data you are going to lose, because you never had any policies in place. Your RTO, it's again not available. You don't know how much time it would take you to recover your server from the given disaster. So this is not a good situation to be in. So what we do here is, let's add a little bit of a solution to our business continuity problem. I'm sorry, I don't see that. Mute my laptop. Aha, okay, sure. You could have told me earlier as well. Okay. Yeah, he does that from somewhere behind. Okay, does it sound any better now?
Yeah, it is just there are the beep noise coming in.
Okay, sure. All right. So what we're trying to introduce here is one layer of some sort of a security and safety in terms of what our disaster recovery looks like. But we'll look at the pros and cons and see how it works. So we know we have a server, and we did not have any strategy of disaster recovery around it. We were just hoping it works fine. But then we add a logical backup to kind of help us with the recovery process in case a disaster were to happen. Now, what happens here is that we have a server, again the hope server, but we added a logical backup which works through Pgconf, which is a binary that you get with PostgreSQL installation. And you configure some sort of a frequency where you take a backup, let's say at 4 a.m. in the morning every day, or maybe twice a week or thrice a week, or whatever frequency suits you. But does this kind of take care of your RPOs and your RTOs, that whatever you define? Your RPO is basically still undefined, and your RTO is still not available. And why? Because your dump is taken at a given point in time, and you still don't know how much data you will lose, right? And you also don't know if your logical backup is valid. Again, more often than not, we come across these scenarios where people have backups, but they are not usable because they never tested them. And this leads to many problems, but it's a silly mistake. You do need to make sure that your backups, when you take them, they are tested somehow. So you need to define some policies around that as well. So with that one logical backup and one PostgreSQL server, we get to a better place if we start testing those backups by restoring them. That takes us a level further. So we try to introduce a restore server somewhere in here, which means that the logical backups that were taken, they automatically, I would assume automatically, because if you still rely on manual process there, it's still not it still does not achieve any objective. It doesn't take you to 40%. So you would probably want to introduce some sort of a restore server where this restores automatically. It happens on many of the places and many of the clients around running PostgreSQL around, that they take logical backups, they restore it automatically to some server, and then they run that server for some other purposes, maybe the BI or analytics or whatever other stuff. So in this particular case, if you are running with this scenario, your RPO is basically your backup frequency. So if you take backup twice a week, that means you can only restore to the most recent backup, which I don't know how frequent you are taking it. If it's a daily, that means you still lose one day's worth of data. Your RTO will be the time that it takes to recover. So if you know that you tested your recovery process, if you know how much time it takes to recover your logical backup, you will have a bit of an idea what your RTO is. But if it is efficient or not, that's a separate debate. So in this particular recovery process, you'll be possibly doing these 3 different steps. 1, you provision another server. 2, you configure the server. Now it's a completely different disaster if this process is not automated, and you have to do it manually, following any of the disasters that happen. In that case, your RTO will probably be much more higher than what it would be with an automated setup. One important point that we are missing here is the time to reaction. So how do we know a given disaster has taken place? In more often than not cases, people don't know whether or not their servers have actually run into a disaster. So this key point is missing from the previous equation that we just saw. So the architecture that we just had a look at, although it takes you to about 40% of business continuity level, but does it work for you? Is it reliable? No, it isn't, of course. So what we are going to assume from here on in is that you have some sort of a monitoring in place, because without that, that previous disaster would never be actually diagnosed or discovered, and therefore would never be fixed. So we need to, our objective should be to basically reduce both RPO and the RTO. So, the amount of data that we lose in case of a disaster and the time it takes to recover from the disaster, that is the objective we need to reduce in order to get to a stable position. So, how do we do that? Well, we do that through point in time recovery. That will try and help us with the reduction of the RPO. This is something that PostgreSQL provides in core. It's open source. It's been there for a while. What you can do is that you can actually build your PostgreSQL server to a given point in time, which is of course a time in the past. Now, your crash recovery basically means that you bring up a new server, you restore some backup on that, and then you replay your existing wall on that to restore it to a given point in time. Now, your RPO is basically a zero data loss policy here. What it does require is that you have a hot base backup, and then you play the remaining wall on top of that, since you had your last wall backup. So that's the concept with point in time recovery. Now, point in time recovery, as I mentioned, it's a process of restoring through recovery process, which will mean that you need to have physical backups somewhere. And for that, you need to have a PG-based backup running somewhere, which will be configured to take frequent backups, just like logical backups. Logical backups is basically something on top of that. You could do that as another safety mechanism, but this is required for your point-in-time recovery to work. So where does Barman come into this picture? The architectures that we just looked at and the problems that we just defined, the RPOs and RTOs, and the idea that we need to reduce them in order to achieve higher business continuity, Barman is something that will help you achieve that. So the current version available for Barman is 2.7. It was released last evening. This license is GPL3. It's written in Python, so of course you can expect some performance out of it. It's developed and maintained by Second Quadrant, and those are the links where it is available, and you can of course look for further information there. Now, let's take a step further and see the problem that we just defined, where exactly it takes us with Barman. So what we do is we have that one Postgres server again, and we introduce a Barman server in the picture. What it does is basically takes a continuous backup of your server. So how do you do that? You basically introduce another server into the picture. It could be a physical server, it could be any virtual server, whatever, but it should have a given amount of disk that you need to store your backups. And I'm assuming that you would want to store multiple backups and not just one backup. So you should plan your disks according to that. So a very simple picture here, very simple architecture. What the concept here is that you can do remote backup and recovery, which means you are sitting on a remote server, you can access your PostgreSQL servers from there, and then you can take backups. So that's one of the features that Barman will provide, of course. Multiple server management, which means you can manage your multiple PostgreSQL servers to take backups. So a single Barman server will be able to take backups from multiple PostgreSQL servers. It will make sure that all those servers information and the backup information is available in catalogs, which you can query by running some basic Barman commands to check a specific health of a given server, the backup health, the backup properties, and a lot more. Then you can of course define retention policies. So for example, I would want to say I need a retention policy of 4 weeks, which means Barman will make sure that you are able to recover to any point within those 4 weeks. So it will make sure that it retains that much base backups and walls. Now the copy method, which Barman will use to provide this functionality, they are basically of two types. One, which is PostgreSQL streaming. So PostgreSQL provides streaming replication. It's been there for a while. And Barman utilizes exactly that in order to implement streaming replication. So you can fire up a Barman utility, which receive wall or receive xlog, as it was on a couple of releases back. So you can fire that up, and it will start streaming in walls from your production server, which means it will have a continuous archival of your running transactions. The other method that it can use is the rsync or the SSH method. So if you give your Barman server access to your PostgreSQL server through SSH, and then you run your backup commands, it will be able to connect with your PostgreSQL server, take base backup, and shift it to your Barman server over an SSH connection via rsync. So the rsync things can be parallelized because you can run parallel jobs there for both backup as well as recovery. So you can do a recovery over an rsync and as well as the backup over an rsync, which supports network compression as well. Now the wall shipping method, the method by which you copy walls, it's basically called archiving. And PostgreSQL has a command that you specify within PostgreSQL.conf. It's a well-known command. You call it archive_command, which by default is a 16 megabyte wall segment that gets copied to your whatever archive place you have or archive storage you have. So streaming, as I mentioned, it happens through pgreceive_wall and pgreceive_xlog, as it was known, which means when you continuously keep getting a stream of data over your streaming replication protocol, you are basically at something like a 0 RPO, because your data loss will be at max to the last checkpoint that you have. So this takes us very close to the original picture that we had, where we were just hoping that nothing happens. But with this, we get into a lot better position. So, but for this, you need a version which is 9.2 plus to work with Barman. An example of PostgreSQL.conf changes that you usually need to do, it's pretty basic in order for the Barman or the replication thing to work. You need to have your archive mode on. You need to have your wall level set to logical. You can, of course, specify some different setting as well. Wall senders, of course, because you'll be sending wall. So you'll need an extra slot for that. If you are using it something for something else or some other wall sender processes as well, then you probably want to provision an additional worker there. Replication slots, of course, these are default settings here. You can specify as per your requirement. Now, archive_command is important here because that's something that we mentioned earlier. You can specify it to copy your wall to the Barman host, wherever it is hosted. Now, this assumes that you have an SSH access to that host without requiring a password. So it will continue copying walls there, which then will be processed by Barman. This is an example declaration of the Barman configuration. So once you have PostgreSQL configuration set up, you can specify something like this, the properties given here, in order to set up the Barman corresponding Barman host. So let's call the server as you can give it any name. I was not trying to use hope here because now we are better than hope. So the SSH command, it basically specifies your SSH connection to your PostgreSQL server. Connection info, again, it gives the connection to your PostgreSQL server where that Barman can use in order to copy the running transactions through wall. So basically, this user must have replication privileges. Retention policy, as I mentioned, it basically defines what sort of a time frame you would want to have in order to enjoy point-in-time recovery. So the point here is that you should be able to recover to any point within this given window as and when the disaster happens. Copy method, for example, it's specified rsync here, and then you have parallel job specified and streaming archiver, which needs to be set to true. It will create a replication slot in order to make sure that your walls are not lost in case your network connection suffers some sort of a glitch. So with this particular approach where you have a Barman server in, are we still in any good position? I would still say no, because your RPO is still unknown. We don't know what sort of a data we would lose, although we are closer to a zero data loss. your RTO, it's still unknown because we have not defined any policies around how much time it would take to restore in case of a disaster. We know Barman will be able to restore, but have we tested that? Did we try to restore to some server to see how much time it actually takes, or whether those backups are healthy? We don't know the answers to those questions yet. So Barman does reduce that risk there, but it does not exclude them. Right? So we go a step further and we introduce a recovery server in the picture now, as we did for the logical backups, because for Barman servers to be of any for the Barman backups to be of any use to you, you must be able to restore them somewhere, and the only way you would know that is by testing them. So there is a restore server. So the picture here reflects a basic architecture where you have a server which is running PostgreSQL. Barman takes the backup and the continuous backup automatically and then restores it to a different server. And that server, although it looks redundant in the picture, but then you can use it for a lot of other purposes. You could use it for analytics, you could use it for BI, you could use it for a lot of other stuff within the organization. It will serve the purpose. But the important purpose that it is serving here is making sure that your backups are actually healthy. So how does Barman restore to a different server automatically? Well, it gives you hooks, and you can write your hooks scripts, then hook them up with Barman, and then that will take care of executing the recovery jobs. So you can define pre and post backup jobs, which means if you have a post backup job, once Barman completes the backup, the hooked script that we have hooked in, it will call that, it will access the remote server if you have defined the access in your script, and then restore your backup there. So that should help you with the automated recovery of your server. And of course, it has a retry option as well. All right, so the example of a recovery script, as I just mentioned, it basically connects to a remote server over SSH. It would stop the running PostgreSQL server there, because of course, in order to restore the backup, you would want to make sure that a restored backup is able to, a PostgreSQL service is able to run on your restored backup. So there is likelihood that the PostgreSQL is already running on the remote server. So you stop it, you restore the data directory by removing the existing data directory and copying over the new data directory that you just want to restore, and you replay the walls. You start PostgreSQL and then you replay any of the walls that you need, and you set this particular script up. That's just the kind of the general idea. You could of course make it more complex to serve your business purposes. So the outcomes of this particular architecture and this particular thought patterns are that you systematically test your backups. It's more important than we think it is. Secondly, you measure your recovery time. This again will give you a matrix of how much RTO you have. So you will be able to define in a given disaster window, we need X amount of minutes or X number of minutes or X number of hours in order to get back into the business. Now, the caveat here is probably that our recovery servers are usually not the exact match of our production servers, which means that if you have a server which is running the restored backup and it is not the exact identical of your existing production or the production that you lost, then you're likely running into a degraded level of service, but still it will give you a backup which will be more recent with very less chance of data loss, and you will be able to come up very quickly out of the disaster. But you need to record this value somewhere. You need to create a metric somewhere. So with this particular approach, we take a look again and see where exactly we stand with respect to our RPO and RTOs. So we know that our RPO is now closer to 0 because we are running a continuous archive of our transactions. Our RTO is our recovery time, the one that we just got from our testing. So we will have a bit of an idea how much time it takes to recover. Whether this RPO or this RTO is acceptable to your business, again, it's a different question. But if you need to bring it closer to the criteria of acceptance, we need to take a few more levels. So the entry-level architecture for business continuity is something that we just looked at, but it's again an entry level. You don't want it in your production. So what our priority should be? To improve the RTO now, because we understand that we have a solution for RPO through our point-in-time recovery mechanism, through our continuous wall archival. So how do we do that? How do we reduce the recovery time? That's through replication. And again, it's been there in core for a while now. It's pretty much stable at this point. You can, with existing vanilla Postgres, you can have one master and then you can have multiple standby servers, which will basically mean that they are in continuous sync with your primary server. So the evolution of PITR, which is the point-in-time recovery, as we had a look at it in previous slide, it basically says that you have a continuously running recovery process on one of your standby modes. One of your standby nodes which is running in standby mode. We call it hot standby. It serves the purpose of read-only queries. You can always connect to it and run your read-only jobs, reporting jobs. It was initially introduced in 9.0, and you can top that with wall files, which is wall file shipping method that as we know it, as part of your archival process. Also, you can create cascading standbys. I know this information is pretty standard by now. So how do we further take a look at the concept of reducing the RPO, the zero data loss policy? So we will look at the synchronous replication. That's another feature that PostgreSQL provides. So you get to define one of your standby servers, or more than one, as your synchronous replicas of your primary server, which means that any commit that happens on your primary server will not complete unless one of your standby servers, which is a synchronous server, also has received the same commit. So it will guarantee that data between at least two servers is in sync at any given point in time. So if the master were to go down at that point, you will have at least one other server which is in complete sync with your master server, and it should be able to take care of the business. So that's the zero data loss here. So what we have now is we have two Postgres servers, one the primary server, second the standby server, which is our synchronous server or asynchronous standby, depends on your requirements. But for the moment, we have two servers. We have one Barman server, which is taking care of the continuous archival and the backups. And then we have one recovery server where we are continuously restoring those backups as and when they are taken to make sure that those backups look healthy. So this picture takes us to at least a couple of steps ahead of the business continuity matrix that we had before. So with this, we are at least at around 80% of the business continuity matrix. What it looks like in picture is that you now have one master, you have a happily running standby, you have a Barman, and then you have one of the recovery servers, which again, as I said earlier, you could use for any other business purposes. Now, how does PostgreSQL.conf look like with this sort of a configuration? You will need to declare something like a hot standby on in your PostgreSQL.conf. You will need to define a recovery.conf for your standby server, and you will need to enable the streaming through defining a primary conf info and of course the restore command. Now in this particular case, if you take a look at the restore command, it refers to a Barman utility. So what happens here is that in case your primary server were to disconnect for some reason, maybe due to some network issue or whatever, your standby server will fall back to receiving those walls that it missed during that time from your Barman server, because Barman server is continuously receiving them from your primary server. So it does not take into account your network strategy here, but I'm sure people who are designing this policy, they will somehow make sure that the network connections are redundant between these servers. A same network connection that's shared between your Barman server and your standby server is not a good recipe, because if it were to go down, of course, your Barman and your standby will both get disconnected. Now, the assumption here is that your Barman server is running on a different connection, which takes care of archival from the PostgreSQL server. So what happens with this sort of a scenario if you need to do a switchover? And I'm assuming a planned switchover. So what you do is you stop your applications, which is the start of your downtime. You shut down your master server, you allow your standby server to catch up to it, and then you promote your standby, which could be a manual process, of course, or could be automated. We'll take a look at that. You switch your virtual IPs or whatever other technology you have in place in order to repoint your applications. You resume your applications, and that's when your downtime ends. And then you have a former server which actually crashed for whatever reasons. So that's still available as one of your masters. You would want to make sure, I'm not taking into account here the idea that some of your applications could still be pointing to your old master. So you need to, as we say, shoot the other node in the head, right? But at some point, you would want to bring that node back into your cluster either as a standby, or you would want to reintroduce that as a master server again. So you need to reconfigure that, and for that you will need to somehow make sure that it is in sync with your current new primary, which you switched over to. In case a failover were to happen which is unplanned, what will happen, the sequence of events would look something like this, that your master goes down, which is your the start of your downtime. You promote your standby, you change the virtual IP or whatever other mechanism that you have in place. But now in this case, you have lost one of the servers. You are down to the reduced capacity, where you either have one server or two servers or whatever they are, but then you have a cluster capacity which is now downgraded. So in this particular case, you still are up with one of these standbys as your new primary. So your applications can keep running, although in a degraded mode. So a manual switchover is not equal to your manual switchover procedure. Let's just keep that in mind. Means a manual switchover is a term that we use for a process, but you need to define that process in whole, how it happens, who executes it, what are the steps that need to be taken if a disaster were to happen. Now, a manual switchover is manually triggered, but again, someone needs to be defined who will do that. In your business continuity matrix, these things should be written somewhere, things should be defined somewhere. You need to automate the procedure in order to make sure that your RTO is minimum. That's the objective that we started here with. You could automate it through bash, that's good. If you have Ansible, that's better. But again, you need to somehow make sure that these processes are automated. And then you need to enhance them gradually to get to a better level of RTO. So a quick look at what we have discussed so far. We have an RPO which is close to 0 now, because we know that our backups have a good frequency. We know that our continuous wall archival is working, and we know that we have tested our backups. So we know that our backups work every time we need to restore them, because that would be one of a bigger disaster if your backups were not to work when you need to restore them. Our RTO the time to reaction plus the time of promotion. So, the time it took us to react is directly proportional to your monitoring time. Of course, if you are not monitoring that often, you will not know the disaster has taken place. So, that is something that counts on that. Your time of promotion, how much time it takes to promote your standby. I am sure it is not going to be in hours. It is still going to be something that you can still work around, though, by making sure that your test procedures are in place and you do switchovers and manual, maybe planned switchovers. So, people, once again, important part of the picture. Now, with respect to your manual failover and automated failover, we need to take a few other concepts into account, which is the split brain nightmare. Of course, that's because sometimes your application or whatever automated procedure you have in place, it could at any given point think that node A needs to be promoted or node B needs to be promoted. We don't know, and both get promoted. Or something like that, where your applications start pointing to two different nodes. Half of your application is pointing somewhere else, half of your application is pointing somewhere else, and they're writing data to both nodes. And that's a disaster that we can hardly recover from, because now we have a data divergence. So, your automated process, whatever you design, it needs to be built on some of your tested processes that you have created. I am emphasizing test a lot of the time, because I have been bitten by this many times, not just in my own environments, but in many of the clients' environments as well, where we go in and where we start working on setups and we figure out that everything that they have was never tested, and it's not even restorable. So this is very important part of the job. So whatever you want to do, keep it manual, automated, that's your choice. So in terms of business continuity, which is the important question here, where exactly we are close to 99.9%, which is probably about 50 to 52 minutes of downtime per year. Is that still acceptable? Well, really depends on your SLAs and SLOs. So where exactly we are, we have two Postgres servers. We are introducing the synchronous standbys. We have one Barman server, and we have at least one recovery server to test our automated backups. And how do we achieve the zero data loss? By introducing the synchronous standbys in the picture. So our primary server has at least one synchronous replica, where it is which is completely in sync with primary at all given times. We have our Barman server, which can also potentially be a synchronous server, because we are running receive all there or receive xlog there. So we can declare that as also one of the synchronous servers. So which means your primary server will make sure that your standby server and Barman server are in complete sync all the time. So the data loss becomes 0 or close to 0. And then, of course, you have a recovery server in order to test your backups. So synchronous replication, it ensures that you have a zero data loss backup. Your primary is having a standby, which is again a synchronous replica. So again, it will help reduce the RTO and the RPO, of course. Now, how you can do that? By declaring just this one parameter in your PostgreSQL.conf file, and it takes you a step further to the synchronous replica level. With this, where exactly we are? Now we are at about 100% of our business continuity matrix in our backup and restore, and in our disaster recovery, and in our HA. We have two PostgreSQL servers. We have one Barman server, we have one recovery server, and if we introduce Rep Manager or any other tool of your choice which can help you with the automated failover, then you have a completely independent setup. Now, The reason I mention Rep Manager here is because Rep Manager is developed alongside Barman, so it has the capability of interacting with Barman for a lot of practical purposes. So, but you could of course use any tool of your choice. So the architecture will look something like this. You have a synchronous replica, you have a Rep Manager witness, you have Rep Manager running both on your primary and your standby, although it's not needed on primary. The daemon, of course, is not needed on primary, but you have it there. The whole idea is that these agents will be able to interact with each other and promote one of the standbys. In this case, there is of course one, but you can have multiple standby servers. So one of them will be promoted to your primary status in case the primary server were to go down. That's the job of the Rep Manager. The witness server in this case is not actually a standby. In Rep Manager or in any other, I think, auto failover tool, you will need at least one other server in order to be able to kind of establish some sort of a consensus on who needs to lead, who needs to actually takes the lead in terms of a disaster. So.
What is the measure of synchronous replication? Is it how much is latency in terms of time from primary to secondary?
That last parameter there. So what it ensures is when you start a transaction on your primary server and you issue a commit, that commit will not complete on primary server until it has completed on standby as well, right?
It's like a two-phase commit.
Yes. So basically, it will make sure that the data is actually committed on standby as well, the one that you declared here, right?
But that will introduce some kind of slowness of performance.
Of course, it will. Of course, it will. But which is why it's a decision that you need to take only if you know your network and your servers can behave in a fashion that you require. If for some reason were to go down, you will have, of course, some sort of a problem with your transactions because it will not be able to commit them, right? So the point here is that one of your synchronous standbys needs to be in complete sync with your master at all given times to ensure zero data loss. Right? So if the primary goes down, you at least have one server where you have complete data.
And in case of we go for asynchronous, that will be just applying the while, right?
It will be applying the while. So you will get replication lag or something. So which means your standby will be somewhat behind your current master position. So therefore, that's why it is asynchronous. So it will not guarantee 100% data copy at any given point in time. Right? Although it could be zero, it really depends on your workload. If you are having a lot of traffic on your primary and the data to sync is a lot in terms of volume, it is possible your standby is not able to catch up as quickly. But there are scenarios where asynchronous is also able to catch up because you just don't have that much traffic.
In that case, the automatic failover option will not be valid because we don't have synchronous replication.
You can still do the automatic failover. The automatic failover is the RTO, right? It's the time to recovery. The data loss is your RPO. It's the amount of data that you will lose in case you have an automated recovery. So what happens is if there is an auto failover in the asynchronous environment, one of your standbys will still get promoted, but the guarantee that it would not lose any data, that's not there, right? So with synchronous, you get this guarantee that at least your standby is completely in sync, or it was in sync when your primary went down. We have 2 minutes? Okay, sure. So what's more, I'll quickly go through the rest of the slides. We have the idea with the Barman is, of course, that you do take your backups, but then you need to store them somewhere, some reliable storage. So you can actually hook them up onto the S3 storage by defining your post backup hooks. As I mentioned earlier, you can define pre and post backup hooks. So if you have a post backup hook that can copy your data onto S3, your backups will reside there. So one of the packages is available by default with Barman, which contains some of these samples that you can modify according to your particular use case. One of them includes S3 backup strategy as well. All right. So what we look at is a sort of a scenario that we started with 0 and we got up until 100. So we moved in baby steps to get to a point where we see a lot of factors. I know that there are some factors that are missing in this. Of course, we don't discuss the human part in this. We don't discuss your organization's capability to handle this. We don't discuss the ability of your humanware to cope with the disaster recovery, the training they will need in order to implement all that. But the plan is around the architecture in which you can come up with something that will ensure you zero data loss policy plus the automated failovers using a tool like Barman. So some of the links where you can get additional information from. Barman, of course, it has its own site. You can go there and you can check out one of the features that came in the most recent release is the Geo Redundancy, which means you can have an active Barman and a passive Barman where one of your Barman servers can actually take its backups and archives from another Barman server instead of actually getting them from PostgreSQL server. That's the one that got released a few weeks back. So some of the information that you can use for your further studies. Thank you. If there are any questions, I know I have already run out of time, but if you do, I will be available outside as well. Can I take the question?
Yeah.
Okay, sure.